Alright, so now we're going to move on to each code, and we're going to go through this. As we go here, I'm going to show you that there's basically two different designs of TCMs, and we'll go over that in just a minute. Excuse me. Alright, so let's start off at P0703, stop lamp switch. So our description here is you're going to see on or off status depending on the brake pedal. This is sent to the cam communication to the TCM. So basically, you're going to get scanner testing. You're going to find the brake switch pin on the scanner. It should read off with the brake pedal released and switch to on when the brake pedal is pressed. For the first thing we do is pull up the PID data, see what our scan tool is reading. Is it changing or not? If it's not changing, then we're going to go to the circuit test. You're going to find your stop lamp switch, check the ohms between the two pins, and then we're just going to press and release the pedal. Alright, so here we have transmission code 705 park neutral position switch. So let me explain what is going to happen on the rest of these slides here. Design 1 TCM has two connectors. So you're going to have connector 1 that has 24 pins and 25 to 48 on the second connector. Design 2 TCM is going to have 1 through 48 pins all in one connector. So design 1 is a two-piece connector at the TCM. Design 2 is a one-piece connector at TCM. So I'm going to go through a lot of these codes, and we're going to have design 1 and design 2. The only difference is the connector pins at the TCM, unless noted. Transmission case connector pin are all the same, design 1 and design 2. Also, when you are doing your pin out checks and everything, it is best to get a wiring diagram for your vehicle to make sure that the connectors and the pin numbers are correct. But these are the two that we have found to be available. Usually, not always, but usually the design 2 is the B model transmission, and design 1 is the A. This is not true in all models, but for the majority, yes it is. Alright, so first of all, description of the 705 code. The park neutral position switch includes 4 switches. For the shifter, the TCM judges the selector lever by the position of the park neutral switch. So when does the condition set? So set condition. TCM does not receive the correct voltage signal from the park neutral switch on pins 1, 2, 3, and 4 based on the gear position, or when the signal is monitored from the terminals of the park neutral switch. So what am I trying to say here basically? There's 4 switches. The computer is not seeing the correct layout of these 4 switches when the shifter is moved. So let's just talk about the 4 switches here. Here is our shifter. In the park position, we have switch number 1, 2, 3, and 4. The switch 3 monitor is basically another wire. It's T to off of this switch 3 here, so you can kind of disregard switch 3 for the most part. This code is looking for these 4 switches right here. So when you move the shifter from park, so in the park position, your switch 1 is going to be off, your switch 2 is going to be off, 3 is going to be off, and switch 4 is going to be off. You move it down to the reverse position, you should see on your scan tool switch 4 goes to on, and you should see switch 1 go to on. Move it to neutral, and you're going to see switch 2 go to on. Move it to drive, you'll see switch 3 to go on. Notice in drive, all 3 switches are on. Move it down to the low position. If it has that position, you're going to see switch 1 and switch 4 go back to off. So this is the logic the computer is looking for. If it does not see this logic, it's going to set the 705 code. Alright, so let's talk about testing this code and how I would do this. The trans range switch is inside the transmission. So switch 1 is going to be on pin 4 of the transmission connector. So over here on the bottom left, transmission connector pin number 4 right here is switch number 1. Trans pin number 5, so this is going to be trans connector number 5 over here on your bottom left is going to be switch 2. 14 is going to be switch 3, and the case connector number 15 is going to be 4. Alright, so there's the switches for the transmission case connector. I put the range switch pins here. This row here is at the range switch connector here. You would use this on the bench if you wanted to bench test your range connector or your range switch when you're on the bench. So how I would do this would be whatever's easiest. Go down to the case connector. Let's work on switch 1. So let's go to the case connector pin 4. So right here on pin 4, we'd back probe that wire. Or if the computer's easier to get to or you wanted to check it at the computer, here is the chart for that. So design 1, which would be this middle connector here, design 1, pin number 27. So pin 27 right here on this connector right here is connected to pin number 4 at the case connector. So this is one wire from 27 to 4 on design 1. Design 2 is pin number 11. So everything's the same. Pin 4 at the case connector is going to go to pin 11 at the TCM on design 2. So here's both of our charts. So how I would do this, I would get into trans switch 1. You know, I'd back probe pin 4. I would move the shifter through the ranges. What's going on our meter? So we should have off, on, off when I move the selector lever through all the positions. If that was good, I'm going to move over to switch 2. Go to pin number 5 at the transmission case connector and do the same test. Move your shifter from each range and you should see a pattern of off, off, on. Move to pin switch 3, do the same thing, go to pin 14 and then move your selector lever through and see if the pattern matches here. Same thing on switch 4 and pin 15. So I would check each individual wire at either the transmission case connector, or you can use this chart to do it at the TCM to prove each wire is good or bad. Alright, so let's move on to the transmission code 710, CVT fluid temperature sensor. First, let me say there's a lot of discrepancies or issues with some snap-on scan tools and some other tools where the transmission temperature says it's 300 degrees, put a temp gun on the pan and it's 180. So there's some software issues with some of the scan tools reading improper trans temp. So before you get too involved in this code, let's prove that if the scanner is working right on temperature or not. So first of all, let's go back to this code. Description: the CVT fluid temperature sensor detects the CVT fluid temperature and sends signals to the TCM just like anything else. The temp sensor is right here on the range switch. The range switch is on the valve body. This is the range switch connector. Pin 2 right here is ground, and pin 1 is your temp signal. This is at the range switch connector itself. So scanner testing, we would look at the ATF temp sensor on the scanner pin, see if the voltage is within the above data. So set conditions: cold, At 68 degrees Fahrenheit, you should be about 2 volts. Hot, 176, you should be at 1 volt. So this code sets when the TCM receives excessive high or low voltage from the sensor. Here's the sensor range. So 0.16 volts to 2.03 volts. If it's outside of those parameters, then it's going to set this code. So first, pull up your scan tool, look at your ATF temp sensor, and see what the voltage is. Second, let's go to circuit test. Let's say it's roughly 76 degrees out, and it's on the bench. Measures pin 1 and 2 here. You should get about 2.5 thousand ohms for the first design. First design has a two connector TCM. Alright, so then if you wanted to do this in the vehicle, we could where is it here? Here it is, trans number. So this is a pin 17 and 19. We could go to pin 17 right here, and 19. We can check the voltage on these with everything plugged in and see what we have. So 17 is going to be voltage, and 19 is going to be ground. If we wanted to do it to the TCM, we're going to be at 47 and 42. So 47 and 42 is your temp sensor here. Here's our early temperature sensor. We have an early and late temp sensor. There's two different ones. So at 68 degrees Fahrenheit, you should be at 2.5 thousand ohms, and you should be roughly 2 volts. At 176 degrees, 300 ohms, you should be at 1 volt. This is for design 1. So let's now move to design 2. Everything here is basically the same. Still have the set conditions of 0.16 to 2.0 volt, 2 volts. So if it's outside of there, it's still going to set the code. Here's the difference. At 76 degrees, you're going to be at 6.5 thousand ohms. So this is the second design. Temperature sensor is still in the same spot. Still the same pins on the range switch, and still the same pins on the transmission case connector 19 and 17. TCM connector numbers change. We're at 13 and 25. So basically you'd want to check your ground. Make sure you have good ground on 25 or on pin 19 at the transmission. Then you'd want to move your meter over to the power side or the signal side, 13 or 17, and see what your voltage is. At 68 degrees, you should be about 1.9 to 2.2 volts. And when the transmission gets warm, 176 degrees, you should be roughly 0.8 to 1.1 volts. Now if you disconnect the TCM here, you can measure your ohms between pins 25 and 13 also. So remember, if you have two different temperature sensors and range switches, you don't want to interchange these or mix these. They do look identical. So interchanging some valve buddies, I see some issues when this is happening. Keep that in mind. You'll want to keep your range switch with your vehicle. Here's the typical wiring diagram. This is the first design. So just basically showing you have sensor ground connected, 42 and 19, and then 17 and 47 is your temperature sensor wire. The only difference between design 1 and design 2 is going to be your TCM connector right here. The numbers are going to be different. Alright, so let's move over to P0715 input speed sensor, primary speed sensor. Primary speed sensor is right here on top of the valve body. And here's your primary pulley, and it's basically is reading off these 24 notches on this pulley here. So description, the input speed sensor detects the primary pulley revolutions. So sensor's reading these lugs as the pulley is rotating. The set condition says when TCM does not receive the proper signal from the sensor. So basically what it's saying is an erratic signal. It doesn't see a signal. It's moving, and all of a sudden the signal goes to 0. It's going to set this code. So with the engine running and you're in neutral, look at your engine speed signal and your primary speed sensor, and you should see them closely matching roughly. You should see that the primary speed sensor is moving. So then you can go to the primary speed signal on the scan tool, driving with lockup on, engine RPM and primary speed signal should be close. So first thing, just looking at the scan tool with the idling, you're going to see the let me think about this here just a minute. If the pulley at an idle, the pulley's not moving. This pulley is not moving in idle when you're sitting still. So scanner testing, you're going to want to be driving this in lockup. Make sure the primary speed sensor is matching the engine speed signal. When I said earlier the engine speed signal and the primary speed signal idling should be the same, that is not correct. What they're wanting you to do here is they're wanting you to look at your engine speed signal, and you want to make sure it is matching the tachometer, engine RPM. So they're verifying engine speed signal first, that way. Then you get on the road, you drive this vehicle. When it's in lockup, they want you to check the primary speed signal to the engine speed signal and see if the RPMs are about the same, to confirm both of those. Sorry about the confusion there. Speed sensor information. This is a 3-wire Hall effect sensor. The sensor has 5-volt power supply and a ground signal and a signal wire. So there's 3 wires: 5 volts, ground, and signal wire. You'll see a 4-wave signal. And then we'll walk through on testing this sensor next. So this is design 1. Here's a typical wiring diagram. The only difference between design 1 and design 2, these numbers at the TCM are going to be different. The trans connector is going to be the same. So if you wanted to inspect the 5-volt signal, we could go from ground to pin 46 at the TCM. So ground and 46, we should see 5 volts with the key on. If we wanted to test the ground side, we could go to pin 42, and with one end of your meter on the ground cable at the battery and one end back probed into pin 42 with the engine running, you should have about 0.003 volts or so. And then if you want to check the signal, you can go to transmission case connector number 22 or TCM pin number 38, and you should have a square wave signal at about 12 miles per hour. You should have around 600 hertz. So this is the design 2, and it's basically the same thing again. One end of your meter is going to be on the ground, and the other end we're going to test either the transmission case connector or the TCM. So same as before, if you want to test 5 volts, you'd be on pin 20 or 46. Test the ground signal, you're going to be on pin 19 or 25. And if you're going to test the signal itself, you'd be on pins 22 or pins 33, one of the other. So just to clear this up, make sure it's not confusing, I'm giving you the case connector pins and the TCM connector pins. Everything's connected. You can test to either one of these connectors, whichever's easiest for you. Alright, so we're going to talk about the P0720 vehicle speed sensor code. It's also known as a secondary speed sensor. The vehicle speed sensor basically is measuring the RPM of the output shaft and creates a square wave signal to the TCM. It will set this code if it sees a sudden drop or raise of RPMs, and it's comparing it to basically the ABS system. So when it sees an erratic signal or a huge change quickly, uninspected signal, it's going to set this code. On the scan tool, go ahead and look at your PID VSP, vehicle speed sensor, and see if it's matching your road speed. This sensor is a 3-wire Hall effect sensor, so it's going to produce a square wave signal. It has on pin 1 a ground, pin 2 is signal, pin 3 is battery voltage. One other note here, there's a washer or shim on some models underneath the speed sensor, so make sure you do not leave the shim or you're going to damage the speed sensor itself. So on design 1, here's a basic wiring diagram here to the left. Your speed signal sensor is here, and your power is coming from the IDPM. Also, this wire here coming off this goes to your TCM on design 1. It's going to be pins 19 or 10 or 19. So if we're going to check the power on this sensor, we can go down to pin 3 at the sensor itself and back probe the sensor here. Make sure we have battery voltage. You can also go to TCM at pin 10 or 19 to check for battery power. With everything plugged in, one end of your meter on ground and engine running, you can back probe sensor pin number 1 right here, or you can go to your TCM pin number 42 and check for ground. You should have about 0.03 volts with everything hooked up and run. Sensor 2, or pin 2 at the sensor, or pin 29 at the TCM, you should see a square wave signal roughly about 300 hertz at 12 miles per hour. So here's the same code, 720, design 2. The only difference here is we're going to change pin numbers at TCM. So everything else is exactly the same. At 12 miles per hour, the factory manual said 350 hertz on design 2. That's the only difference. But all the pin voltages are the same for this code. Alrighty, so now let's keep moving on. We're at P0725, engine speed signal. This is for design 1 and design 2. The engine speed signal is sent from the ECM to the TCM. Set conditions. The engine speed signal is detected when the TCM does not receive engine speed signal. So basically the engine ECM is seeing the speed signal, but the TCM has no speed signal, no reference. It's basically is inputted by the CAM communication from the ECM. So what we can do for scanner testing, in the transmission we could look at engine speed signal and see if we have a signal there. Is it the same to TAC? If not, we need to go to the engine side, the ECM, and check the engine speed signal on the ECM side. If you have a reading on the engine side but not on the transmission side, then we need to check the CAN bus system. At this time, it would be best to go into all modules and look for communication on all modules, see if we have an issue with your CAN bus system. If you have no if you have no reading on the engine side, we would start checking the crank sensor and the sensor itself, and the signal to the ECM to see if we have a fault on that side. There's basically are no wires to test from the ECM to TCM, except the CAN bus wires itself. Not much you can do on the CAN bus wires to see if it's missing that signal or not. You would want, if you do see a signal in the ECM but not in the TCM, the next thing would be to start checking powers and grounds and all your communication. Alright, so P0730 and P0730 in the gear ratio for design 2. So they have two different names on this. Some scan tools may call it the same, but first design they're calling 730 a belt damage. Second design you're saying a gear ratio code. Basically what this is, a TCM selects the gear ratio. So it's using your engine load, throttle position, road speed, primary and secondary speed sensors, and it's changing the ratio as you're speeding up. So basically what happens is when the computer is asking for a certain ratio and that ratio is not achieved, it's going to go ahead and set this code. So the gear ratios have to be between 2.37 and 0.43. So the 730 code is detected when the TCM receives unexpected gear ratio detected. So if you see a slip in the bell, or if the ratios don't match the desired and actual ratios don't match, it's going to set a 730 code. So we check the gear ratio PID on the scan tool, and also check your speed signals and make sure they're also working good. Of course, on this condition you want to check, of course, your fluid condition, pan condition, fluid level, all those great things. This is usually caused, or one thing that can cause this is a flow control valve issue. Stuck pulleys, balls that are broken up in the pulleys or the grooves, and sticking pulley. That can also cause this. Usually get some pressure codes with this code also.